Welcome to WETO Tutorials. Today, we're going to take a look on the Roof Assistant and the Roof Profile Editor in VisKon 18. We're going to see in detail what kind of parameters can we manipulate with these features. Let's start by creating a T-shaped roof. To do this, start a new project and make sure to check the Roof Wizard or Roof Assistant. Set the base plate to 10 by 10 meters or 1000 centimeters. And once you press OK and generate your first 3D view, you will already see the base plate. Then the program brings up the parameter list, which we will close for now. You can fill it out later as well. The next window is the wizard, which always starts with setting up the building's stories, because we have the story manager here. In the upper left corner, you can see two preset levels that you can rename by double-clicking them. Also, on the left side, further down, there are a few buttons. First, you can integrate the roof into an existing story if you have one. The next option generates the walls, which we will configure later. Below that is the command for creating the ceiling, and the last box relates to layered walls. Below the checkboxes, the Add Story button creates new levels in the building. See, we have another level named Story 1. And the Delete Story deletes them accordingly. The Set as Default button will save the current settings as default values, as is right now. And the Apply Default button restores these defaults if we set anything else. Now, the pictogram on the right side shows a stylized image of what has been set so far. Here you will find the same values as in the list on the left. See, in the loft we have these parameters, the same as here. For easier work, these values can also be modified here on the pictogram. For example, I can increase the ceiling height to 300 centimeters or the slab thickness to 20, or even wall thicknesses 25. Moreover, I can also choose the type of walls here. All I have to do is click the Select Walls button, and this brings up a list of preset layers from which we can choose the appropriate wall type. We have all these presets already in the program. This list can also be edited and expanded with other types, but we have already covered that in another video. Once all settings are done, we can move on. On the next screen, we need to select a starting floor plan for our new building. This will be the basis for our design. Let's now select the T-shaped floor plan. And click Next. This screen will define the shape of our roof. Here too we can choose from several options. There are hipped roofs, gable roof with hexagonal extension, or even monopitched extended roofs. Let's choose the half hip roof with extension for now. And click next. Okay, the size input helps us decide on the external dimensions of the building. I will change this value to 750 and this one to 250, so that gives us 10 meters. On the other side, the edges will be 3, 4, and again 3 meters. So this side will also be 10 meters. Okay, we can move on. Now, we have the opportunity to place interior walls in the building. I will make one as an example. First, select the story where you want to place the wall. Then the wall type, if you want a layered wall. If you just want simple solid, then set its thickness. I'm gonna set it to 25. After that, click the new interior wall button and move the cursor onto the floor plan. The first click sets the starting point of the new wall, and the second click finishes the command. Once this is done, you have the option to fine-tune it. You can fill in the fields here with the exact parameters, for example 350. After each parameter, press the tab key and you will see the changes. You can set the length as well, but it's not that important because I'm going to show you why. By clicking the accept button, we finalize the new wall. And if you are not satisfied with its position, you can delete it. And if the problem is that it doesn't reach the other wall, simply click the fitting the inner wall button, select the wall and align it to the outer wall. And that's all for the interior walls. The next window manages the openings. Again, level selection is important. Ground floor. And then click new opening. Give it an approximate position, either on the inner or the outer walls. Click and fine-tune it with the fields. You can also decide whether it is a window or a door. Now I will place a 110 centimeter by 120 by 210 centimeter door, 0 sill height. The position is gonna be 403.5, so it's in the middle exactly. After clicking the accept button, you can modify or delete the openings with these two side buttons. Okay, let's continue. We have reached the most interesting part of the roof editing. Here is the profile editor. On this top view, we can choose which planes we want to modify. If a gable is not visible, you can also press the next profile button and it will cycle through all profiles, whether visible or not. Now let's enter the profile editor. We will first examine this double pitched roof more closely. And here we are on the first tab, the profile/slope tab. Here we get a comprehensive picture of how the roof will look. Basic modifications can be made here, such as roof angle or inclination, profile width, overhang, or eaves height. Beyond that, we can also add new bands to the roof planes. Let's add a new one with a 25-degree inclination, and we can switch between these bands with these arrows. Also, the roof assembly can be set here. I don't want to spend too much time on this because there are a lot of settings here. As you can see, you can easily get lost in the details. Perhaps the most useful thing here is the roof tile selection, which can be found here. We have some textures for roof tiles. Okay, we return to the main screen. Next to the parameters, you can see these buttons with 3 dots. Let's see what they do. For the roof angle, it opens a window where we get 2 variables. One is the inclination and the other is the ridge height. I can set these 2 parameters as fixed, to which the other roof plane will adjust. As you can see, as soon as I change something, the roof shape in the background changes. For this I use the tab key. See, can do this. And next to the ridge height value, you will also find a button, and this opens another window up. This is useful because for more complex roofs like this one, this window allows us to align the ridges to each other. By checking the lower purlin box, we hide the purlins, leaving only the ridge lines visible. I select this other ridge as a reference, and the program adopts this height for our new ridge height, 349. We save the changes, and on the main screen we will see how the profile has changed. In the lower left corner we can also see the entire roof from above. The small blue arrow indicates the direction of this side view here. Okay, there are more hidden menus like this. The profile width also has a similar button. Clicking it will again open a window. Here we can fine-tune the widths of our planes. To be able to move the planes, we need to set a pivot point. I generally recommend the first option, but the second may also work in some cases. If I change the value, you will see the difference between the two. Check this point out. Right now it's set to pivot on the purlin plate. So when I change, this is the point where the whole slope pivots. But I change it to the eaves point. Now, see what happens. Yes. This point gets fixed and everything else changes. But the first one is usually the best bet. And now you can see these two profiles. Alright, and here You can also set the reach height, but we have already discussed that earlier. Okay. I will show you one more such menu. This will adjust the eaves height. The button next to overhang is currently not assigned to any function, but let's look at the button below it. This brings up another type of window. Here we can set in detail where the eaves should fall. There is also adaptation methods here which help shape the roof. Let's choose the modify support height option. Once this is done, click on the button here, and this brings up a window similar to the reach height adjustment, but now we set the eaves. It highlights in red the plane we are working on. I will select the eaves of the other roof plane so that the program aligns the eaves height of the large roof plane to this one. We save everything and check the result. You can see that the roof has changed. Finally, note that so far we have only worked on one side, on the left side. But we have both right and left sides here. Do we now have to do the same thing again on the other side? Well, no. That is what the transfer button is for. It can copy the settings from one side to the other. And this applies not only to this tab, but to all the others as well. As you can see, we have a transfer button here, here as well, etc. So every single setting can be copied. Let's do this, and we have equal sides now. Okay, now let's look at the other tabs. The next tabs concern the individual elements, and they come in pairs. So the rafters, the purlins, the purlin plates, and the middle purlins are all divided in two. The right and the left sides each have separate tabs for each element. So let's continue with the rafters. On the left side rafters, the first thing you can customize is the cross section. Let's set it to 10 by 20. Alright. And then there is the material selection. It is C24. It's alright. You can set what happens where the rafters meet at the ridge. There is a straight plumb cut or half lap joint, or you can even add a back cut. But usually we use this half lap joint. And if you use this, you can also specify the diameter of the bolt which joins these elements. So I can set it to 1.2. Moving on, you can also set the shape of the rafter ends. You can cut the rafters in various angles, even with a second cut or without. And you can even give them a custom profile if you select that one and click on this button. We have all kinds of head profiles, or you can create your custom ones. For now, I will select this one. And yes, these are roughly the main options. If you click transfer, the other side will get these dimensions as well. Okay, let's look at the purlin plate. First, there are a few boxes. The first one deletes or creates the purlin itself. The second gives it a slope. And the third one creates a notch for the rafters. After that comes the cross section, which gonna be 15 by 15. After that, the notch size in the rafter, which is 17, it's alright. And finally the position of the rafter, and the reference line is the outside contour of the wall. Let's set the side distance to 5. Okay. Here too you can select the material and you can specify different reference points for the beveled cut of the purlin. Something like this. Finally, you can also give this element an end profile if you want to. And all parameters can be copied to the right side as well, just as we discussed. Nice. The next element is the middle purlin. Here the options are almost completely the same as for the purlin plate, but there is one difference. There can be multiple purlins on one side. If you click the new button, you can request a new element, and this can be another middle purlin, an independent one. Let's set it to, I don't know, 200, for example, yes. Or it can even be a double beam. If you check this box, the double beam. And now this support becomes 2. The rest is basically the same as on the purlin plate. Okay, I'm gonna transfer it. And, so far we have covered the elements that come in pairs. Now let's look at those that are single. The next one will be the color beams or ties. This tab starts similarly. If we don't need any color beam at all, we just uncheck this checkbox, but now we will need it. Below that, we can see the positioning of the color beam. It can have 4 positions relative to the rafter. It can be on the right side, on the left side, or the center. Back cut should be deleted. Okay, or it can be on both sides. The next option also concerns positioning, but it defines the vertical position. We can align it to a purlin, to be above the purlin or between the purlins, or you can also place it freely almost anywhere. The cross section is set here, 5 by 15 for example, and below it is the parameter for the free placement. Let's put it on 250. Okay. And give it 1 centimeter of back cut. Yes. We can also place insulation, generate insulation between the elements. And at the bottom, there is a button to create a new color beam or delete the existing one. Finally, there is also a button to specify the bolting. For example, 1.2, and we have the joint. Okay, and our last tab will be the ridge purlin. This is almost identical to the purlin plate. However, there is one thing I would like to highlight. At the bottom, there's a button called Ridge Straps. This is a very useful function because in some roofs it may be necessary to have smaller collar beams. These can be set here with size 5 by 10, alignment, and bolting included. Okay, now that we reached the end of the tabs, let's go back to the beginning. After we have set everything for this pair of roof planes, copy all parameters to the other roof planes. We can do this with the Transfer Multiple button. Click it, select the planes you want to modify, and click the Transfer button. It is very important to press the transfer first and then the OK button. Once the changes are applied, you can press the OK button here on the main screen as well. And with that, just a few more steps remain before we can finally see the model of our building. Click the next button. On this page, we can set the automatic layout of the rafters. We can input the distance between rafters, I don't know, 90, and set them to align with the edges of the walls. Fix rafters to the wall and wall distance -10. Okay, finally, the valley rafters can also be adjusted to size here, 15 by 20. Once all this is done, we can move on to the final step. Click on the Done button and find the location for the building. The outline is already visible when you start moving the mouse. Place the outline with 2 decisive clicks, 1 and 2, after which you can refine its final position with exact values. I can add or subtract from these parameters, but for now I'm gonna make it 0. And note that you can also mirror the building along the X and the Y axis if needed. Then, if you are satisfied, click OK. Wait a few seconds and your building is ready. Finally. Well, some later modifications might be necessary. For example, we don't need these collar beams. But with good planning, you can achieve the perfect shape even on the first try. After that, all you need to do is create a summary of the material quantities. We get this here at the top on the output section, and click on this command, computation list output. Save the file, test2, and then press OK on the pre-selection window. After a few seconds, you can browse the complete material list for your new house. If you also need a printed version of this list, you can freely export it in a Microsoft Excel format from where it can easily be printed. Just give it a few minutes to generate everything. And here we have the exported Excel. So that was this demonstration. I hope I managed to spark your interest in WETO even more, as it has many useful functions. These all make work easier, whether you are a builder, designer, or just an enthusiast. Thank you very much for watching. Don't forget to check out our other tutorials as well, and have a great day.